Okay, hi everyone. My name is Jamie MacNaughton. I am going to show you this website called Seeing Theory today. The web address is up here, but if you just Google Seeing Theory, you'll see it come up. Up here in the top left, we got a couple links. Pretty simple website. Got a couple languages you can choose from, which is nice for any non-English speakers in your class. You can hit start, and that will take you to the chapters here. A couple other little things. Here's the about. So this was created by a student that was an undergraduate at Brown University. This first guy here, and then he's got a couple people who have joined to help. But I love that this says the goal of this website is to make statistics more accessible through interactive visualizations. So that's really the goal of what this website is. And I think it does a great job of doing exactly that, just making statistics a little more accessible for people who are not mathematicians, I guess, or for people who are just learning it. They've also got a book that goes along with this website. It's a draft, I think, but you can download the PDF for free. I've got it pulled up here. But basically, it's by those same four people as the authors. And the chapters in the book actually match up to the 6 chapters that are on the website, which I think is really nice. But each one kind of goes into more detail. It's written very well. I've read through a couple parts of it. I like when math texts are written just kind of with plain language, but it also does a great job of actually showing the more complicated math. Obviously, this would be for more like a statistics course where they have a lot of prior knowledge of high level math skills, but it is nice that it kind of goes along with the website very well. Okay, so to get right into this, if we go to chapters, again, here's those 6 chapters across the top, and then each one has 3 different visualizations that you can look at. So there's a couple here, and I want to go through just to kind of show you how this works. So here's in our chapter 1, basic probability. Our first visualization is about chance events. I think this would be great to use with any level student. It'd work great for middle schoolers, but also for high school, just learning about probability, or a simple intro in a stats class even. But this is the stuff that most kids know. It's about flipping a coin, right? Most students know that if I flip a coin, the probability that I get heads or the probability that I get tails is 50%. It's a half, right? But I do like that each one, by the way, has this kind of description that talks about it just in plain language over here. But there is also some great math vocabulary thrown in each one, and you'll see some of them have a little more complicated math involved, but there's always a very basic explanation I think just about anybody could understand. But the best part is I can actually interact with this. So we've got our true probabilities over here. If you hover over each one, I've got a 50% chance of each one, and then I can flip the coin and see what happens. Well, I got tails, so in my experiment, 1 out of 1 times I got a tails. Flip it again, I got tails again. Flip again. That time I got heads. So now I've done 3 coin flips. 2 out of the 3 are tails. 1 out of 3 is heads. And I can keep doing this, but what I like here is now is a chance to talk about why do these green bars not match the blue bars, right? Why are our experimental or our observed outcomes not matching our theoretical or our true probabilities? So it's a great discussion you could have with your class. But, we might ask, why is there a flip 100 times button here? Well, if I click that, what's going to happen to my probabilities? Oh, look at that. That's the first time that's happened all week. But if I click on those, normally it doesn't jump right to 50% right away. Actually, if I hit it again, it might go a little bit off. No, it's still there. But we can keep hitting that 100 times. Usually it kind of takes a few times to get to that 50-50. But, that's one thing you could ask your students, how quickly can you get to that 50-50? You can also change the probabilities of your heads and tails. Maybe it's not a fair coin. Maybe it's weighted. So it's more likely that I get heads. How does that change what happens when I flip my coin? Well, we're going to expect to get heads a lot more often as I flip this, right? So I keep going. I keep getting heads. And eventually we would expect to get tails. There's one. And again, we can do 100 times. How many times do I have to do that to get it to match? That's pretty close, but it's not exact. If I keep doing that, maybe I'll get closer and closer. But how many times do I have to flip it to get it to get there, right? But I think that's a great way to visualize that. Normally, if we do this in a classroom to do an activity, we might have an actual penny where we flip the coin several times, and then we make like a frequency table with X's or something that we mark on a chart, and then we make a bar graph to kind of see these things. This kind of lets them see it immediately as they flip this coin and simulate that. Rather than throwing a penny around. And it's more colorful, it's prettier to see, it's nicely lined up, and it shows them how to organize a graph when we're looking at that. So I really like it. We got a couple others here for expectation. And then down here, we also have variance that are very similar. If I do this over and over again, what happens to the expectation, which again, we can kind of talk about as an average. But we see this blue line here is what we expect it to be. And then we can see what our average actually is after that many times. And again, we can hit the roll 100 times for the die. And we see how that line gets closer and closer to our expectation of the mean, right? We've got a little more complicated math here. But again, I think even without teaching this in a stats course, we could still use this visualization and talk about it without really needing to understand all of that background math. But it's also nice that it's there. It makes it a little more mathematically correct. We've got accurate representations of our math. We're not hiding from that more complicated notation. We're saying it's there, but maybe we don't understand it yet, but we can still look at this and understand it. And same thing with variance, right? We can do the same thing there. We'll look at a couple more of these just so you can kind of get an idea. I like some of these in the compound probability. This set theory one I think is even great for several different things. You could use this for sets, just that you do in Algebra 2 or in pre-calculus. I do some things with Venn diagrams in my quantitative reasoning class. Again, you've got to kind of have some vocabulary of set language and how that works. But once they have that prior knowledge, you could use this to say, what do I have to type in this box to get just this centerpiece to highlight? Or, what if I want everything outside of the circles to highlight? What do I have to type in here? And you can kind of use your pieces here, your intersection and unions, and then hit submit and see what gets highlighted. And it shows you that up here as well, what you typed in, reset it and redo it. So I think that one's really nice and kind of like a quizzing way to see, how are they doing with that? But also letting them explore it and see, okay, well, that's not what I wanted to highlight. How do I highlight the thing that I want instead? There's another one here for counting, which again could work for several classes. I really like that it compares permutations and combinations, and I can switch between the two and see how that changes from looking at, well, order matters, but over here, order doesn't. And if you watch carefully, like up here is my AB and here is BA. And if you watch those two, those lines converge to go together to just one option there instead. It's kind of neat. We can change the number of marbles in the bag and then see our combinations. We can change to just 3, just 2, etc. to see how many options we end up with there. The other one that's great here is this conditional probability with these kind of falling dots, and they change colors as they fall through the different pieces. So each one has its own individual probabilities, and those are all set at 1/3 right now. If you hover over this carefully, the white arrow here moves the bar where it is. And we also get a black arrow that lets us increase or decrease how large that is, which will also change what happens down here. So that's kind of neat. We can interact with those. And then if you click on one or the other, you can then look at the conditional probabilities once you're zoomed into those and kind of see how that works. There's a link here from what this visualization comes from to this Victor Powell's. And I actually really like this one as well. I think this one is a little more detailed than what seeing theory has on theirs, and it explains a little bit more of the math and how they get there, but um, shows a lot of stuff. It's got counts here all in real time. So I really, really like this as well. You could kind of expand on that. Again, this seems, whoops, wrong one. The seeing theory may be a little more straightforward, a little more simple to understand. And then that other one, if you want to go further with it, you could. And then after that, we've got some stuff with distributions. Random variable was one that, I didn't think there was a way to visualize it, but you can actually choose a whole section here of this and then assign it a value. And we can do a couple of them, make them as big or small as we want to. And then we hit sample down here. And as it samples that distribution, it comes up and shows us how often it lands in that piece. And again, does that in real time and shows us our values on each one. So something there that I really never thought of a way to visualize that helps a lot, I think. Discrete and continuous with our probability mass and cumulative distribution functions. Again, those are nice to see. I think these two would have helped me a lot in our class last semester on statistics. And then from there, chapter 4 and chapter 5, oops, not too far, back here, go on to a bit more complicated subjects. We've got Bayes' theorem in here, and we've got some regression analysis and correlation, and those get a little bit more complicated, but again, I think they're great for a statistics course. As far as our, things we talked about in this course with the mathematical fidelity, pedagogical and cognitive fidelity, I think it passes most of those tests. All the math is very accurate, and oops, the cognitive fidelity, that they're going to expect certain things when they see it. I think it's all very well done on this website. The one thing I think that's maybe missing from this that other ones have is it doesn't really have the activities that we've seen with Desmos and GeoGebra, where you can create a step-by-step process that students walk through on their own. I would consider probably using this more for, say, a supplement as I'm teaching a lesson. So, we got to this part. Now let's go visualize what it looks like. And we do it as a class. Or, everybody take out your computers. And now that we've learned a little bit about this, go see what it looks like. Or I think some of them, like the conditional probability expectation, some of these you could have like a worksheet that goes with it where it's got questions that the students answer as they work through it. But again, that would have to be on paper, that they're still interacting with the technology. I think the students are getting feedback in one way on this, that as they do something, they see the effects of it. But it's not something where they could answer a question and then get feedback from, what did I answer it correctly or incorrectly? But I just think it's a different type of technology tool. It's not something that we're going to use to quiz our students or test their skills as much as it is just enhancing their understanding of kind of complicated topics. So I love it. I think it's great. I'm excited to try to use some of these in my quantitative reasoning class and, see how that helps with our stats unit when we get to it. So hope you guys like it and enjoyed.